Hi guys, today we're going to be jumping into lesson 6.3, writing two-step equations. It starts on page 185 in your book. We are not going to be doing the modeling of the two-step equations that you see for that first page, the explore activity right now. I do think that that's something that is valuable for you and a partner to work through. I know that there's another example in lesson 6.4 that you could look at to help you better understand it. We can go over this on Friday when I'm back in school, but it's not something that I'm going to do in a video for you right now. It's not something that's on your test, but if you're a visual learner, it's definitely something that can help you understand what's happening in these problems. But for now, we are going to move on to page 186. Don't turn there right now. I just want you to see the problem and not see all the work in the book right now, okay? Just look at the problem. Let's work through it together. It says, a one-year membership to Metro Gym costs $460. There is a $40 fee when you join, and the rest is paid monthly. Write an equation to represent the situation that can help members find how much they pay per month. Go ahead and read that again in your head, and seek to understand what the problem is looking for. Okay. All right, so when we were writing equations yesterday, we were realizing that there was a pattern of these equations, right? Especially when we were doing addition and subtraction. It was almost like what you were starting with. You were starting with something, you had a starting point, and then something happened, right? We either added or subtracted something. And then we had an end point. Do you remember that? And so we were kind of like, yeah, this is a good way to think about it. And we get to the end. Okay? And so let's think about this problem this way. So it says a one-year membership to Metro Gym costs $460. Now, if I think that through, that's how much I pay after a year. So there's a $40 fee when you join, and the rest is paid monthly. Okay. So we don't know how much is paid monthly, but we know that they pay monthly. So that $460, let's go back to that. Is that your starting point or your end point? Yeah, it's your end point. That's how much you pay after a year. So we know that that's going to be on the right side of our equation for now. Just for these purposes, could it be on the left side of the equation? Totally. If we flip these around, we could use properties and we can move that to the other side. But for our thinking purposes, since we're just learning this for the first time, let's just set it up this way, okay? And at the start, before you even exercise for a day, what do you have to do? Your starting point is you're paying $40, right? And wouldn't that be like a y-intercept? Before you even step a day in the gym, you're paying $40, right? And so the rest is paid monthly. Well, this is really important because this is a one-year membership and this is monthly. So when we're doing this, are we going to add or subtract our monthly fee to the $40? Yeah, we're going to add it. We have to pay something, right? And so we're paying some amount over 12 months times this monthly fee. We don't know how much we pay monthly, but we know we do it over 12 months. And so our equation by the end of it ends up being 40 plus 12m equals 460. This is a really tricky problem because there is no 12 in here. But we have to know that we have to multiply by 12 in order to go from monthly to a year-long membership, okay? So we're kind of converting units in a way. This is a two-step problem, and you're setting up the equation in this way. I know that some of you are like, oh man, I could already solve this. I know how to do it because we've done something similar to this in the past. And so it's not until lesson 6.4 that we actually solve these equations, but I think some of you are ready for it now, so I'm going to show you how to solve it, okay? Remember when we did this in the past, when we solved two-step equations, you had to, we do PEMDAS when we're moving forward, but you kind of do reverse PEMDAS when we're undoing a problem. And so we actually have to take care of the addition and subtraction and undo that first. And so over here, I got to get rid of the 40 first. And so on both sides of the equation, since this is a positive 40, I have to undo it, and I have to get rid of it, and to get the m by itself, which is my ultimate purpose, is to find out what m is. I have to get rid of that 40, and whatever I do to one side, I have to do to the other side. And so these two cancel out. That becomes 0. And over here, I have 420. And then I'm left with 12m equals 420, right? And in order to get rid of that 12 and have the m by itself, I have to do 420, or I'm sorry, 12 divided by 12, and that cancels out, become 1, and so I have 1m, right? And I've got to divide this by 12, which equals 35. So my final answer is m equals $35, because we were talking about that monthly fee. And in order to do my check step, I could do my check step up here. I could do my check step, and I would replace that with 35, the m with 35. And so let me change to a different color for you guys. I would do 40 plus 12 times 35. And I want to know, does that equal, so I ran out of space again, does that equal, with a little question mark here, 460? Okay. And so 12 times 35 equals 420. So 40 plus 420. Does that equal 460? 460 equals 460, and I'm good to go. I know that got a little sloppy there, but I hope you're able to follow along with my thinking. Okay, so that is going to be the first problem that you need to do. Like I said, this one is a little tricky because you didn't have the 12 in there. You had to know that you're converting from months to year, and that's how you do that problem. So make sure you're reading really, really carefully to make sure that you have all components of the problem, because sometimes they can get a little tricky. Okay, so moving on to the next problem. Here's another example that you can work on. It says Billy has a gift card with a $150 balance. That means that's what he has left on the card, okay? He buys several video games that cost $35 each. And after the purchases, his gift card balance is $45. Write an equation to help find out how many video games Billy bought. Go ahead and read it again in your head. And let's talk it through. All right, so following that same pattern, we can look at a starting point. Something happens, right? Something happens. And then we get to equals the end point, right? All right. And so, looking at this, what is our starting point? Is it going to be the $150, or is it going to be the $45, the $35? Where are we starting at? Yeah, our starting point is $150 because that's what he had on the card, right? And then something happens. He does what? He buys video games. So we've got to ask ourselves, if we're buying video games, are we going to be adding or subtracting to this? And in this case, you guys got it. He's buying something. So we're going to be subtracting this $35. But he's doing this $35 a couple of times, right? We don't know how many video games he's buying. So each time he buys a video game, it costs $35, but he does this several times. And so it's going to be $35 times, let's do V for video games, okay? So 150 minus 35 times V, however many video games he buys. And our end result is going to be $45. And so that is our two-step equation, okay? That's how we write it, because we start at 150, he bought a $35 game several times over. We don't know how many times he did it, but then by the end of it, we end up with $45. Again, I think you're ready to be able to solve this equation right now. And so I'll show you how that's done, because I think some of you are ready for it. Just like our previous problem, when we're undoing it to find out the value of our variable, we have to do the reverse PEMDAS. So instead of undoing the multiplication and division first and everything, I need to undo the addition and subtraction. So this is a positive 150. In order to get rid of that, I have to subtract the 150. If I do that to one side, I have to do it to the other. So 150, negative 150 plus 45 is going to be negative, because that's the larger absolute value is the negative 150, so it's going to be a negative number. And I'm going to subtract these two, remember that? And so I'm going to end up with 105. Got that? And on this side, I'm left with negative 35v. These two are canceled out, but I'm left with this negative in front of it because there's a negative right there, so I'm left with that negative. So negative 35v equals negative 105. Now I want to find out what the v is, so I've got to divide because it's being multiplied. So the inverse of that is divide. They're being multiplied, so I have to divide to get rid of it, right? I could divide by 35 on both sides. So divide by negative 35, I should say. Okay? And so these two cancel each other out. I'm left with v. It's good because it's a positive v, and that's what I want. And 105, just to double check myself, 105 divided by 35, it should be 3, but let me double check myself, is 3. And so, looking at that, the V stood for video games, and so Billy bought 3 video games. I can do the check step by rewriting the problem as it was and replacing the V with a 3. So I would do that up here as a check step. Oops, I'm sorry, I didn't mean to go on to the next page. My check step would be 150 minus 35 times 3. Does it equal, that's a question mark I'm putting up there, does it equal 45? And since I'm going forward this time, I had to do PEMDAS, so I had to do this guy first. Okay, right? So 35 times 3 equals 105. So I would do this guy first. I don't know why my pen's not writing. There you go. 150 minus 105. Does it equal 45? And 45 equals 45. So I was correct. Okay? All right. Last problem of the day. Okay? All right. In this problem, we actually have to create the word problem that is represented by the equation that's given, okay? And so it says, write a corresponding real-world problem to represent 5x plus 50 equals 120. I think that our method of thinking actually helps us a lot in this situation where we have a starting point and something happens, and then we have equals the end result, right? And so I'm looking at this problem right now, and I have 5x. Something happens where 5 is being multiplied by an unknown number, or something that's unknown. And then something happens, suddenly I get 50 of those things. And 50 things. And then by the end of it, I have 120 total. Okay? And so I've got to think of a situation which will allow me to have something that's multiplied by 5. Let's say that, okay, let's say that somebody is babysitting, and for every hour that they babysit, they get $5 per hour. So it could be the starting point, you get $5 per hour, right? Per hour. And then something happens, you get a Christmas bonus. You were doing a really good job at babysitting, and so the people who you're babysitting for give you a $50 bonus. So $5 plus $50, and in the end, you end up with $120. And so my question would have to be, how many hours did you work? Does that make sense? So this per helps me to know that I'm multiplying by the x, and so the x would be, the unit of it would be the hours. And so you just have to think of a scenario. You have to be a little creative with these problems and think what could be represented by it. And so my problem could be that Bethany works as a babysitter and earns $5 per hour. I'm using my finger. My stylus isn't working on my iPad, so sorry about that. Per hour as a babysitter. she receives a $50 bonus as a gift. How many weeks will it take, or how many hours will it take her to earn $120? Will it take her to earn $120? Pretend I wrote the rest of it, okay? Her to earn $120. Okay? So that's how you write your problem. You just have to be creative. You can look on page 187 for other examples of how to create the two-step equation, or at least the word problem based on the equation as you have it, okay? So your homework right now, your classwork and your homework is to complete page 188 and 189 and 190. All of those pages for the questions that ask you to complete the tile models, the algebra tiles, to do the modeling of it. You do not have to do that. You can at least just solve the equation. You don't have to model it. If you would like to, go for it. I don't expect you to draw the pictures for it, but if you would like to learn that way, you can. And but at least solve the problem for it, okay? And just do the math for it to be able to model the given equation. I hope you have a great day for the sub. Please make sure you're following expectations for her. You can work in a group. If you finish early, you can work on any other assignment that you need to for any other class for today, or you can read a math magazine. If you have any other ideas to show your learning, or if you would like to create a YouTube video for one of the things that we've had done in the past, or if you want to update your notes, please feel free to do all of those things as well. I fully believe that you're going to use your time really well so that you can prepare for your second trimester final and your Module 6 test that's going to be coming up soon, okay? All right, you guys have a great day, and I'll see you Friday.